Alrighty, geometry students. I know you've missed the videos. We're back because we're on a new chapter, chapter 4. This is lesson 4.1. Chapter 4 is all about triangles, and we're going to be doing a lot of proofs later in the chapter, proving triangles congruent and lots of fun like that. But first, chapter 1 or lesson 1 is a nice little intro on just classifying triangles. So we've got some definitions here, and there are a series of just different types of triangles that we'll want to get straight, and then some inform some questions to flesh out some final ideas. So let's jump right in. Definitions. I'm not going to write out the word triangle. You're going to see that I like to do it. I just write this symbol. You'll enjoy abbreviating too. So first definition is an acute triangle. And as you can see there, all angles, again, not going to write out the word angle, just going to put an angle sign with apostrophe S. All angles are less than 90 degrees. Okay, so triangles have 3 angles, always, and those angles always add up to 180 degrees. But in an acute triangle, all of the angles are less than 90. So a real simple example would be, because you should always draw an example, would be something roughly like this. And this is, you can see in all of these angles here, here, and here, none of those are more than a right angle. So that would be an acute triangle. It could also look something like this, unless you think the sides all have to look kind of equal. Again, you can tell none of those angles are more than 90 degrees. Okay, so that's what we call a cute little angle. Alrighty, and actually I'm kind of out of order, but so I want to jump down. I want to do obtuse just to contrast that. So an obtuse triangle is one with one angle that's greater than 90 degrees. Be careful, it's only one angle. So you can't have a triangle with all the angles greater than 90 degrees. So just make sure you catch that detail. As long as the triangle has one angle greater than 90 degrees, it's obtuse. And so that might look something like this. Draw a nice big one just to make sure I get the angle right. But you can see here I've got an acute angle. Here I've got an acute angle. But this one up here, you can see that angle is a nice wide angle. And if you were to turn it, you can see that's more than 90 degrees. So that is an obtuse angle, more than 90 degrees. If I even labeled these, you could do something like this, A, B, C, and you could say angle B is greater than 90 degrees. And so for that reason, we have here an obtuse angle. Whereas, let's go back to number 1, and then acute angle, and maybe I'll just undo the same thing, angles A, B, and C. Here, we'd say angle A and angle B and angle C are all less than 90 degrees. So that's what makes it acute versus obtuse. Then we have a type of triangle that's equiangular or equiangular. And that's where all the angles are equal, because you can see that's equal angles. So pretty simple. That would look like this, kind of like the one I just drew above. And because all the angles within any triangle in existence add up to 180, there's only one specific type of equiangular triangle, and that is where every single angle is equal to itself and equal to 60 degrees. Okay, and actually let me write it this way. 60 degrees, 60 degrees, 60 degrees. So there's only that you can't have one that's 30, 30, 30 or 45, 45, 45, because all the angles in a triangle have to add up to 180. So you know, if you have an equiangular triangle, you know that every angle is 60 degrees. 3 times 60 equals 180. Okay. Then we get a right triangle. We've already talked about these, but they're not an obtuse triangle. They're not an acute triangle. They're one in between, where one angle is equal to 90 degrees. Okay, so that's a right triangle. So we've got acute, obtuse, and right. Equiangular, where all the angles are the same. And actually, let me go ahead and make that clear. That angle there is 90 degrees. It's a right angle. That's why we get the hypotenuse there is the long side. Then we have obtuse angles. Equilateral. So we have equiangular here. That's where all the angles are equi. Here we have all the laterals being equi, i.e. the sides. Your muscles here, these are your lats. They're your sides, okay? And then they are equal. So this is a triangle that looks like the equiangular but in this case, all the sides are congruent. And there's no set amount. Those lengths could be anything from anything, but as long as they're all the same, that would be equilateral. But what you can do that we want to take note of is also an equiangular triangle. We're going to learn this later, but I'm going to give it away right now. In other words, if you have an equilateral triangle, you also know that all the angles are equal. So another kind of a sneaky secret just to confuse you, equiangular triangles and equilateral triangles are the same. If I know all the sides are equal, all the angles. And if I know all the angles are equal, I know all the sides. And so we're going to add that here. Also, equiangular is also equilateral. The only difference is if you know the angles, you know they're 60. The sides, you don't know. They could be anything except that whatever they are, they're all the same. Okay? And then that leads us to, we've got two more to do, an isosceles triangle. Okay? That is, we've already have a triangle where all the sides are equal. Then there's a type of triangle where two of the sides are equal. And that is what we call an isosceles triangle. So we would only hash through two sides right there. So we know that we've got two congruent sides, not three congruent sides. Otherwise, it'd be equilateral. So isosceles means two congruent sides. Okay? I'm going to give you a little bonus fact here. That also means they have two equal base angles. And what that means is that if I know those two sides are congruent, making an isosceles, I know that these angles down here, just the base angles, are also congruent. And we'll be using that more, but I want to start front loading that idea for you guys right now. Just like equilateral has all equal sides and all equal angles, and isosceles with two equal sides also has the two congruent angles. Okay? And then you might be able to see there's one type of triangle, then a scalene. If we have a triangle where all the sides are congruent, equilateral, we have a triangle with where two of the sides are congruent, isosceles, then you have a triangle with no equal sides. Sometimes I struggle to draw these because it looks like they're close. That kind of looks like an isosceles. Could probably do a better job of this than me. Let's try again. Fail. Maybe just something like that. No equal sides. I'm not sure how else to say it. Otherwise, you could say something like this: A, B, C, and you could say side AB does not equal side BC, and that does not equal side AC. Make it very explicit. None of the sides are congruent. They're all different, even though AB and AC look kind of close. So scalene means nothing is the same. No sides are the same. Okay? So we've got, and you notice we've got, you're either classifying triangles by their sides or you're classifying triangles by their angles. Acute, obtuse, right, equiangular, equilateral, isosceles, or scalene. All right, now we get to our questions. Here we go. Question number 1, imagine triangle DEF. Name the 3 pairs of sides and the vertex formed by each. So the name of this triangle, you'd write triangle DEF as I've written there. But what this question is doing is it's just getting you used to naming the sides and parts of a triangle. So I'm going to just draw it, and it could look like anything because we get no information about what this triangle looks like, except that it's D, E, F. And so we need to name all 3 sides, all right? So let me first of all name this side right here. That would be side DE. And we'd write it like that. The other side would be just right here. And if we're talking about that side, we call it side EF. And at this last side here, that would be side, oops, I should call that there, side DF. Okay, actually, I'm going to keep going in the same order. So I'll say side FD. So you got DE, EF, and FD. Just to make the point, the order doesn't matter. So the DE is the same as ED, EF is the same as FE, and FD is the same as DF. So those are all the same, talking about the same sides. When we say vertex, When we say vertex, we are talking about the corners. Whoops. The vertex, that word means the angles, or like I just said, the corners. And so when we're talking about the vertexes, we would write that as that we have angle D, and that's this one right here. We have angle E, and so that's this angle right here. And then we have angle F. And of course, that one is right there. So just so when you're having to name sides and angles, this question is just getting you warmed up for how to identify them. Okay, whether it's a side or an angle. Okay, so now we get into just some classification questions. So number 2 says, sketch an example of an obtuse isosceles triangle or explain why that's impossible. So we're trying to put together these classifying characteristics. An obtuse triangle is a triangle that must be an angle is greater than 90 degrees. And isosceles means we must have two congruent sides. So is it possible to draw a triangle that has one angle that's not less than 90 but more than 90 and has two of the sides are equal? Yes, there is. It would look something like this. Okay, what I call kind of the barn roof. Because here, this angle right here, if you look, that is greater than, whoops, the wrong way. It's greater than 90 degrees right there. So that makes it obtuse. And then this and this, by my rough approximation, could be the same length, again, like a pitch of a roof. So that's, so the gable of a roof, that's your example of a obtuse isosceles triangle, okay? Because it meets both requirements. One angle is more than 90 and two of the sides are congruent. Okay, number 3. This one asks if every acute triangle is also equal angular. And again, explain and support your answer with a sketch. So an acute triangle has to have all angles less than 90 degrees. An equal angle would have to say all the angles are congruent. Whoops, why am I writing that out? Let's just abbreviate it. All angles congruent, i.e. they would have to be 60 degrees. So is that true? There's no other way for it to be acute? No, this is wrong. You could draw, again, kind of a little acute angle like this. Actually, let me make it even clearer that they're not all the same. Okay, all those angles are less than 90 degrees. And you could even just make up a mount. So like just say this one is 20 degrees. Actually, this one looks more likely. 20 degrees. And so maybe this one here is 60 degrees. Oh, maybe that'd have to be bigger than that. This one actually maybe looks more like 80 degrees. And then that would leave the other angle to equal 80 degrees. So that's fine. So I have 3 angles, all less than 90 degrees, and yet you can see not all the angles are congruent to each other. They still add up to 180. So no. Or is every acute angle? So my basic answer is no. And you can use your sketch. Actually, maybe I'll write it over here. No, you can have 3 different angles, all less than 90 degrees. I'll explain it. Okay. Write that out better. It looks like a W. Whoa. No, you can have 3 angles that are still less than 90 degrees. So the answer to that is no. And again, this is just getting you used to the different classification terms and using them to imagine specific triangles. So number 4, last one, is it possible to draw an equilateral right triangle? So equilateral means all sides congruent. And a right triangle means you have to have a 90-degree angle in there. Okay? You can see for a second that that's going to be a problem. First of all, you can realize it's a problem because we said that equilateral triangles, if all sides are congruent, all the angles are congruent. And therefore, they would have to all be 60 degrees. So that's going to be a problem because that doesn't allow you to have a 90-degree angle. The other way you know that's wrong is that you can see if I draw a right triangle, So first of all, because I have to have the 90, so that can't be 60. And we've learned that all right triangles have this thing here called a hypotenuse, which is also known as the longest side. Right? And you can't have a longest side in an equilateral triangle. So this is a case of it being very incompatible, and so the answer would be no. You could say it this way, equilateral triangles can't have a 90-degree angle because they have to all be 60. So that would be one reason. You could also write out the reason being the hypotenuse. Okay, so want to learn and just keep practicing. The key is the different classification and realizing which ones can be compatible, like the isosceles obtuse, or which ones can't be compatible, like the acute equiangular or the equilateral right triangle, and various other forms. So that's kind of what those are some of the exercises. That's what they'll have you practicing. All right, thanks for tuning in. Good luck. Look forward to seeing you in class and working on this.